Welcome to solverfy.
Okay, so I see that you need help with this question, and it wants you to first do the data provide sufficient evidence to conclude that the mean monthly time spent in volunteering for female and male student differ. Test the significance level of 0.1 with a degree of freedom of 35. Okay, so for the female, if I have the mean is 17. The sample size is 49 and 0.99, and degree of freedom. Oh, the degree of freedom is 35. Oops. 0.99. The degree of freedom, and it doesn't say what to round to, so I'll go out 2 decimal places. And degree of freedom is, again, 35. So sample size is 36. And then standard deviation is 5.6. 5.6. So if I calculate that, we have for the female, you're going to do, so I'll do female first, and then I'll do the male. It would be 17 plus or minus 2.72 if you're looking at your T chart, times the 5.6 divided by the square root of 36. So 17 plus or minus 2.72 times 0.93. So 17 plus or minus 2.54. So then that confidence interval is going to be 14.46, comma 19.54. And then for the male, the average is 15, and the standard deviation is 7.2. And so if I do 15 plus or minus the 2.72 times the 7.2 divided by the square root of 36. So if I have 15 plus or minus 2.72 times 1.2, and then 15 plus or minus 3.27, then the confidence interval is going to be 11.73, comma 18.27. So the data does provide sufficient evidence to conclude that the mean monthly time spent in volunteering for female and male students does differ, because the confidence interval does differ. Find the 90% confidence interval for the difference in the mean monthly time spent in volunteering between the male and female. So the mean difference for 90%, if the average of the female is 17, the sample standard deviation for the female is 5.6, and the sample size is 49. And then for the male, it's 15 is the average. The sample standard deviation is 7.2, and the sample size is 36. And again, I'm going to round to 2 decimal places. And so the first thing that you need to do is you need to calculate, or you need to pool their variance. So the degree of freedom for the female is 48 and 35 for the male. So you're going to do 48 times 5.6 squared plus 35 times 7.2 squared. Then you're going to divide that by 48 plus 35, and you're going to get 40. And then you're going to find the square root of that, and that's going to be 6.32. And then you're going to multiply that by 1 over 49 plus 1 over 36. And you're going to get 1.39. That is your standard of error. Then you're going to take your degree of freedom, which is going to be this If you add this together, you're going to get 83. So then you have to calculate now your confidence interval. So you have is 1.90. So 1 minus 0.9 equals, I'm going to go back to the black one, 0.1. And then 1 minus 0.1 divided by 2. And that is 0.95. And then you're going to take that 0.95, so t 0.95, your 83, and you are going to get 1.66 for your t-score. So then you're going to calculate your difference between your means. So 17 minus 15, which is 2, plus or minus 1.66 times your standard deviation. I'm sorry, your standard of error of 1.39. So 2 plus or minus 2.31. And that is going to be negative, your confidence interval of negative 0.31 to 4.031. So does this interval support the conclusion of the hypothesis in part A? Justify your answer. No, because it includes 0. So I hope that this video helps. This is middle school math teacher signing.